So today we will be solving the Leetcode question number 62, unique paths. It's a medium question. First read the question. There is a robot on a M×N grid. This robot is initially located at the top left corner. That means grid 0, 0. The robot tries to move to the bottom right corner, to the last corner, to the bottom corner. So the robot can only move either down or right at any given point of time. So you will be given a mid-term matrix. You need to find the number of possible unique paths that you can reach from the start position to finish position. That means from the top left corner to bottom right corner. So first let's take the 2 into 2 matrix. So this is the start position, this is the final position. So this is the 1 1 1 2, this is the 2 1 2 2. So this is a 2 into 2 matrix. So now we are at 1 comma 1 position. So in the starting position, now we have to find the number of unique ways that you can reach from 1 1 to 2 2. So what we will do is we come from the backward. We try to, in this video we will try to solve this problem from the backward. So from 2 2 we will try to find how to reach to 1 1. So first you are in position 2 2. That means you are in the final position, so you don't need to make any move, so it is 0. So from 2 comma 1, how you can reach from 2 comma 1 to 2 comma 2? So there will be only one way. We can move the right side of 2 comma 1, so there will be only one way. So now 1 comma 2, from 1 comma 2, how you can reach to 2 comma 2? There is only one way, you can go down only. So there is no, you can't go to the right because that's the end of the matrix. So it will be only 1. So now 1 comma 1. So from 1 comma 1, either you can go down or you can go right. So that means you can go to the 2 comma 1 or can go 1 comma 2. So here 2 comma 1 and 1 comma 2 we already calculated. So 1 plus 1 equal to 2. So there will be two unique ways that you can reach from 1 comma 1 to 2 comma 2. Now we will try to solve a bigger matrix, 3 into 3 matrix. So this is 3 into 3 matrix. So now let's say we will backtrack this problem, like we start from the finish position and we try to find from finish to start position. We will find from the backwards. So 3 comma 3, it's a 0 because you are in the finish position. So now from 3 comma 2, there is only one way that you can reach to 3 comma 3, that's you have to go to the right side, so there will be one only. So from 2 comma 3 you have to go down to reach 3 comma 3, so there will be one way. So now from 2 comma 2, so from 2 comma 2 either you can go to the right side or down, so only two options available, that is 2 comma 3 and 3 comma 2. So here we already calculated the 2 comma 3 and 3 comma 2, so this is 1 plus 1 equal to 2. So next, so what all we have completed, so this one done, this one done, this is done, this is done, this is done. So now let's find it for 3 comma 1. So 3 comma 1 you can't go down, there is only one option left, you have to go to the right side, 3 comma 2 position, 3 comma 2. So 3 comma 2 is 1. So next 2 comma 1. So from 2 comma 1 either you can go down 3 comma 1 or you can go to the right side 2 comma 2. So 3 comma 1 is 1 and 2 comma 2 we already calculated, it is 2, so it will be 3. This one also completed, this one also completed. Now let's calculate for the 1 comma 3. 1 comma 3. So there is only one option left, you have to go down. So 2 comma 3, it will be 1. So next 1 comma 2. So either you can go to the 2 comma 2 or 1 comma 3. So 2 comma 2 it is 2 and 1 comma 3 it is 1. So total 3. So finally we are reaching to the starting position. So now 1 comma 1. So you can go to the down 2 comma 1 or you can go to the right side, right side 1 comma 2. So 2 comma 1 is 3 and 1 comma 2 is also 3. So total 6. So 6 is the answer. There are 6 unique ways that you can reach from start to final position in this 3 by 3 matrix. So in similar way you have to can do for higher bigger matrices, 4 into 4, 3 into 4, 5 into 6, like any kind of matrix that you can do. So one important thing you need to remember is, so here you can see 2 comma 2. So here 2 comma 2, so we are reusing this 2 comma 2 from the previous calculation. So you have to memorize the calculations while going further, so that you can use it in the next iterations. So at every point you need to store the results in some memory in cache. So when you are going to use that, you have to cross check whether that key is already in that cache, then you can use that already calculated results. So it's a very basic dynamic programming problem. So next we will solve this. We will write a code for this problem in Java and Python. So we try to do it with recursive and memorization technique. Okay, now let's write code in Python. So first I will be creating one memorization hash map. So init self dot memo. So created one empty dictionary. So currently pass. Now we'll create one function. Self, so it will take the position, the m into n cross matrix. So it will take the m and n the values. So now we create one key value m comma n. So first we have to check for the boundary cases, like if m is less than 0 or n is less than 0, that means it went out of the matrix boundary. So in that case just return 0. So or else if m equal to 0 and n equal to 0, it means it reached to the starting position. From the final to starting, we are coming from the backward, right? So in that case just return 1, like if it reaches to the starting position. Now you have to check this key is present in the memorization in the memo also or not. So if it is, just return the written it from the memo key. Yeah. So now you need to store the current m comma n position in the memorization table. So key equal to, so here the main part comes sub.dfs. So now from the final position you have to make one more to left and one more to bottom up. So it will be m minus 1 comma n. So plus self.dfs and m comma n minus 1. So from that position we are moving left and moving up. So we are taking the combination of both ways. So and storing it in the memorization table at that key. So now return the current key. Yeah, that's it. So just return self.dfs minus 1 comma and minus 1. So it's a matrix, right? So it starts with 0 the arrays. So make sure you check all those things. Yeah, here we made a typo mistake. Right. Submit. So accepted. Okay, now let's write code in Java. So first I'll be creating one memo array. So I'm creating one empty multi-dimensional matrix. So it's filled with zeros. Now I create one function. So it will return the int m comma int n comma on we're taking memo also. So yeah. So now you have to check for the boundary cases. If it is crosses the matrix boundary, the boundary of the matrix, then you have to return 0. So it is less than 0 or n also less than 0, just return 0. So if it reaches to the starting position, then it reaches to the final position, so just return 1. So that means it came from final to the start, from the back to front. So that means if there is a unique path is we find out, so we are returning the 1. So now you have to check the current position whether it is already calculated or not. So if memo, if it is greater than 0, that means it's already filled with some value, so we can use that value. Return memo of m of n. So now you need to calculate it for the current position. So m1 n dss n minus 1. So you go one position to left and one position to right. M comma n minus 1 memo. So finally just return that. It's not catchy. Memo. So I always use these words memo and catchy. So just return memo of m of n. So just call this function comma n minus 1 memo. Everything is fine. And yeah, semicolon. Okay, my bad. So it's not 1 comma 1. So in the array it's 0 comma 0. So if it reaches to the 0 comma 0 position, that means it reaches to the starting position. So make sure you check all those conditions properly. Yeah. Submit. So that's it for this video. Thank you guys. Let's meet in the next video.